In 1903, Michael Tzvedt, a Russian botanist working on photosynthesis, published a paper describing a series of experiments he had conducted on chlorophylls. In his paper, he announced he had discovered a way to separate the various pigments that occur in the leaves of plants. Even before 1903, it was known that these pigments contained green chlorophylls and yellow xanthophylls and carotene. However, separating them was extremely difficult, and complete separations were seldom, if ever, achieved. As part of his experiments, Tzvedt constructed a simple apparatus consisting of a narrowly drawn tube with a filter paper cap over the tip. He packed the column firmly with powdered starch and then filtered his extract of the plant pigments through it. As the solution passed through the column, bands of the individual substances separated into layers. Tzvedt noticed that the separation could be improved by following the pigment solution with a wash of pure solvent. The resulting distinct color bands of the yellow carotene, then the yellow xanthophylls, and then the green chlorophylls, once separated, were easy to collect and purify. In the ensuing 3 years, Tzvedt continued to develop his new method of separating plant pigments, and in his papers of 1906 he called the process chromatography, a name derived from the Greek words for color and to write. These seemingly simple experiments set the stage for a revolution in the means of purifying and separating mixtures. Although he did not fully understand how the process worked, it is now known that Tzvedt's original separation was based on the relative equilibria of the plant pigments binding to the starch and dissolving in the solvent. When the mixture of plant pigments was added to the top of the column, all of the different components of the mixture were absorbed by the starch. Then, as solvent was added to the top of the column, the pigments were washed off or eluted. Equilibria were established between the pigments in the solvent and the pigments on the starch. The most soluble and least tightly adsorbed pigment, in this case carotene, dissolved to a larger extent than the pigments that were not as soluble or more tightly held, such as the xanthophylls and the chlorophylls. The soluble pigment carotene moved down the column with the moving liquid. As it moved down the column, the carotene encountered fresh starch and was reabsorbed on the column. Equilibrium with the solvent was again established as more liquid passed down the column. The more soluble pigment kept moving down the column and was eventually eluted from the column. Therefore, the most loosely bound pigment, carotene, moved down the column first, slowly followed by a band of the next most loosely held pigment, and so on. The distribution of any solute between two phases is related to the relative equilibria of the substance in the individual phases. This ratio of the amount of solute in each phase is known as the distribution or partition coefficient. Because this distribution coefficient is a ratio, in successive extractions of a solution, the solute being distributed can eventually be quantitatively removed from one phase to another. All types of chromatography are based on these kinds of equilibria. By keeping one phase, such as the starch, fixed or stationary and allowing the other phase, called the mobile phase, to percolate through the fixed phase, continuous equilibria can be established along the length of the column. Small differences in the distribution coefficients of the components of the mixture can give an analytical separation of the species. For Tzvedt, the choice of solvent and stationary phases was largely a case of trial and error. In fact, he tested over 100 solid phases before concluding that starch gave the best separation. The choice of stationary and mobile phases is still somewhat arbitrary. However, with a better understanding of the equilibria involved and the factors governing them, a more informed judgment can be used in selecting the phases. For example, an organic chemist encountering a mixture of relatively non-polar compounds will frequently separate the species with a strong adsorbent, such as silica gel or alumina, using organic solvents of increasing polarity, such as pentane, ether, and alcohol for the mobile phase. On the other hand, a biochemist who more often deals with large molecules uses gel filtration chromatography to separate the components of the mixture.
Even though the choice of stationary and mobile phases depends on the species to be separated, the procedures that must be followed to gain a good separation on a chromatographic column are common. The basic piece of equipment used in chromatographic work is a tube with a sintered glass disc at its bottom. This tube can vary from a few millimeters in diameter and a few centimeters in length to one much larger. However, a burette of the right diameter and length can be used equally well, providing a small plug of glass wool or cotton is used in place of the disc. The glass wool should be gently pressed into place at the very bottom of the column with a glass rod. To prepare it for packing, the tube or burette is clamped securely in an upright vertical position. Great care must be taken in packing, since this is the most critical operation of the entire procedure. An irregularly packed column will not give a good separation, regardless of the care taken during the remainder of the process. A thin layer of clean white sand is poured on top of the glass wool. This helps to prevent the finely powdered stationary phase from leaking through the glass wool or clogging the disc. Care should be taken to ensure that the sand layer is level. Any sand adhering to the side of the tube can be washed off with a small amount of solvent. If more than one solvent will be used, the solvent with the least eluting ability is used as the rinse. A slurry, that is, a mixture of the solid phase or adsorbent to be used, and a solvent, can be used to pack the column. The stopcock is closed. The slurry is then poured slowly into the tube and allowed to settle.